last time we talked about like deriving new type instances, and so that was pretty cool. And today we're going to discuss type classes, or sorry, more type classes, but overlapping instances, and then let's see what else we're on. Orphaned instances, instance dependencies, multi-parametric type classes, and functional dependencies. So here we go. All right, so let's take the following instances. We can like bring up the compiler error, but like it's right in here, so probably not a big deal. So we have this overlap data type with its single occupant, and we try to like implement two show instances for it. And it doesn't like this because this one overlaps with this one because, like, you know, they do have different names, which is kind of interesting. It would be kind of useful if you could name them, but I don't know how you would use them. Like, I don't think there's a way to use this name. It's just kind of there. Don't quote me on that, though. Yeah, there'd be no way for the compiler to resolve which one of these to use. Okay, so class combine. Oops, I need a type. And down here we'll just run spoggle build watch for now, in case we want that. Okay, so instance combine int. Oops. I assume that this is imported. Okay, that comes from Prelude, so we're good. And now we want instance combine int where combine mult. Okay. So the problem is that we have two ways of combining ints in the same module, package, or program. It would be fine if we had one way for ints and one way for strings, but in this case we have two ways for ints. There's a way out of our quagmire by creating new types for int, one type that combines using addition and another uses multiplication. Yeah, this is kind of what's done in Haskell, something like this. So you have I think it's just sum and product type and data constructor that make this work for you. All right, so let's keep going and see what happens. So instead of using ints, we're using add ints or mult ints, and there's no ambiguity and no overlapping instances. But what if our types aren't monomorphic? Okay, so I think there's really like no way around this particular one, so I'm just gonna comment this out. So this is like C semigroup sum and product, or sort of let's write this. Instead, use new types for sum and product, semigroup, and implement. Okay, so now this one is a little more tricky. I think it should copy okay. We just kind of got to delete some stuff here. And move this and move this. Move that as well. I wasn't paying that much attention when I wrote that, apparently. Okay, so now we have an overlapping instance error. Whoops. There we go. Middle finger that time. All right, but in this case, it's like this one's more special. This is slightly more specialized than this one. So I assume that there's probably some sort of way to describe that this is fine, is my guess. So anyway, let me get rid of this though. Okay, so we have this is record, and it's basically just saying like if you give us a record, we'll give you true, otherwise we'll say false. Cool. What we need is a way. Oh, weird. Interesting. Else instance. Whoa. So it's like you're saying like you can fall through this instance into this instance. Can you do yet another one? I mean, it wouldn't make sense in this particular case. When using instance chaining, order matters. So if we were to swap the instance order, the compiler will not complain. It just will never use the second one since A will match all types. Interesting. I've not seen this before. So if we don't get a record, fall to the next overlapping instance. In other words, this one. Pretty cool. I didn't know that that was a thing. So, like, this book has already been pretty useful because we learned a lot more about new types and the way you use them. And I learned this, which is not a thing in Haskell. You have to use an overlappable pragma to deal with this. I think the behavior is the same, like the order matters, but don't quote me on that. I'm not 100% sure how it works in Haskell. I don't use it very often, but I think this is pretty cool. All right. So what if we actually, yeah, so I want to just add another one of these and see if you can have multiple. Oops. Instance is record other has been defined multiple times. Oh, I see. So first off, let's remove a few of these things. We really want this, and we don't need this. We don't need a name, so let's just remove it. Okay, yeah, then it just works. So the reason that that failed is because I used a name and I specified the same one. I guess that this is just giving it like a custom name so that it doesn't have to be concerned about, you know, you naming it wrong or whatever. Neat. Okay, cool. That is neat. All right, orphaned instances. There are some restrictions on where we can define instances of classes, and for good reason, which will become apparent soon enough. Instance must either be defined in the same module as the type class, defined in the same module as the type. Person type, person, yeah, perfect. Okay. So in option A, we have defined person's instance in the same module as the type class. Option B defines person's instance in the same module as its type. Cool. All right, so then we have this in like 3 different modules. Or 4, I guess. You have another, like, just instances all over the place, and they're not in the same modules. Okay, so what we need is an authoritative definition, and there really is only 2 places of authority. the module where the type class is defined and the module where the type class or the type is defined. Okay. This may seem limiting, and frankly, sometimes it is, so much so that in Haskell, there's ways to tell the compiler to allow orphaned instances. However, this is not without risk. If this is overused, then it's possible to wind up with two disparate definitions of the same instances. Yeah. Okay, so in pure script, this is disallowed with no override possible. But what happens when you do find yourself with an orphaned instance? Let's look at such a case. Okay. So we've got rid of this. We need to get rid of this defined class. So let's just do this. And then import combine class combine. I don't know where this comes from, so we may have to go look it up real quick. Pursuit s combine combine. Can I write class here? Maybe not. Okay, like I would have to like create some modules and do this probably. Okay, so the type of class is defined outside the module. The int type so you don't control either the type class or the type, but you want to make the type have additional functionality. What can be done? Make a new type. Sure. Makes sense. Wait, what? This will cause a type mismatch error. This one makes sense to me. If you try, you'll get the following type error. Oh, I see. So hey, Will, how's it going? Yeah, my trip was really good. I went to San Francisco for a week. Super fun. I had a really hard time adjusting getting back. I don't know, like the time zones really messed me up, and I was kind of surprised by that. I didn't think it was going to be so bad. So, but yeah, it was super fun. Now we're just, back to the grind. Okay. So, yeah, we would need a semigroup. Or a semi-ring. I've never implemented a semi-ring, but it apparently has like an add and a multiply. So that's kind of interesting. Okay, so while new type allows us to sidestep the orphaned instance problem, it is not without its downside. Many times we need to implement the underlying instance for our new type using derived new type. Euclidean ring, commutative ring. Jeez, that's a lot of rings. We derive the new type instance. Although we don't understand what a semi-ring is, we can leverage the underlying implementation. This lets us subtract add ints. Why would we want to do that? So 3. Why would we want to subtract something called add ints? Not really sure. This lets us divide add ints. Commutative ring is a superclass of Euclidean ring. Okay. It feels weird to introduce all of this right now. Hey, Commander, how's it going? Like, it's just strange to me that you would implement, like, why even explain this stuff right now? I find this a little weird, but I guess it's fine. It's just, we were trying to get plus. We were trying to get plus. So it seems to me like if you just show this and then say, hey, this is how you would get plus, technically it also gives you minus. Or sorry, this allows you to add and multiply integers using the semigroup operators, or excuse me, semi-ring operators in this case. I just find it a little weird to introduce this now. Anyway, not a big deal. I understand like what the point is. The point is there are no orphan instances allowed, and to use orphan instances, you need a new type wrapper. Anyway, okay, so instance dependencies. Instances can also be constrained. In other words, an instance depends on one or more instances. So we have an instance for show maybe, where the A is showable. So this is probably just the implementation of this. So I think it would actually error if we try to add this. I also thought the fat arrow went the other way. But that's for like super classes. Is that the right term? I don't know. What are those parentheses for? Why would we want these? Seems like we don't want those at all. Ah. Yeah, so this is an orphan instance for show. So the only way we could actually do this is creating a new type. Okay, so is this the same book from which we tried to implement index previous time? I think so. Yeah, it should be in chapter 5. I think the code's up online now. And yeah, so actually we're doing a lot, like much simpler stuff, I think. Well, it might be really confusing for people who have never done like this type of language before, but it's not too bad because I've done Haskell. Anyway, if we wanted to do this, we would also need a new type wrapper because it's an orphan. Well, okay, if we defined maybe inside here, actually we can just delete this and then do like they're doing here. Then it's no longer a oops. Oh, there's a typo. Page 247. I just want to write this down so I can tell. Charles. Page 247. Instance dependencies. Data maybe should be data maybe A. Okay. The name X was shadowed. Okay. Somewhere in here I have something called X. X. So we're gonna change this to I don't know. like that, so we don't have a shadowed X. Okay. I assume we're going to use X here in a little bit. Yep. Here's another example. So in this case, we need both A and B to be showable. Cool. Okay. Multi-parametric type classes. Decapitate. Okay. So it takes some kind of collection and pulls off the head. Yeah, behead. Which is fine. So you could implement it for list as just uncons, and apparently there's also a string.uncons, which I didn't know was a thing. Yeah, it's kind of a strange name. Like, you could just say like, it could just be like take first item, or it could just be uncons, since we use that term for like lots of things. But yeah, like decapitate is pretty dark. There's a few dark examples in this book actually. But anyway, the general idea is like you're taking a collection and it has like a certain type, right? So a list of A has A's, string has cars, you know, something like this. And so if you wanted to take a single element from the collection, this is how it would have to look. And then you could just implement them. Okay. The list instance is said to be polymorphic in the second type parameter. Remember that poly means many and morph means shape. Second type parameter A can take on many shapes. In other words, A can unify with many types, which it should be able to, right? Like this is, you can implement this for any type that you can make a list out of, which I think is just anything. Okay. In contrast, the string instance is monomorphic in the second type parameter, because this is a character. Remember that mono means one and morph means shape. Cool. Very neat. Functional dependencies. Returning to our string instance for decapitate. This is the non-Unicode version of string, but what happens if we support Unicode also? Then string to code point. Not use code points much in PureScript, but I'm pretty sure I knew that they existed. Maybe. But yeah, this is from a different module. You'll see. Where is it? Code units. This is on the non-Unicode code units. I don't know how I'm supposed to know that one is Unicode and one is not, but okay. You might think that this is a case of overlapping instances, but it is not. Decapitate string car is different than decapitate string code point. Yeah, that makes sense to me. Let's keep these implementations in mind as we look at the function to return the tail by leveraging instances like these. So for all collection and element, or and element, give me a decapitatable collection and element pair, a collection, and I might return you a collection. So if we can case this thing, okay, so let's just bring in this, I guess. Well, really, we don't even need an instance. We just need the class. Okay. And then we got to go down here, and then we're going to grab generic tail. Need to tab that out, remove this, remove that. Okay, no instance found for collection to T1. So it doesn't understand what element type we're using, I think. Like this function only understands the collection element, and so it can't, I guess it can't pick the version of T1, which is the element type. So I get in Haskell, you would just like say, I think just like that, but that's not a thing in type applications are not a thing in PureScript yet. I don't know if they will be, but anyway. So there are two ways to fix this. One is a bit hacky, and another involves functional dependencies. Let's not look at the hacky way. Let's completely skip the hacky way. As it turns out, there's a cleaner way to communicate to the compiler what the type of our element should be. We can use a proxy. So I'm not a fan of like going over like hacky solutions. That's just not particularly interesting to me. So I would like to see like what is the real way we can handle this thing. And I think this makes sense. Like all you're doing is fixing the type here, so you can then say that this is. Although it's weird to me that you need the proxy at all, right? Like, why do you need the proxy at all in this case? You have. Well, let's just try it. So this is going to be head, tail, collection of. Oh, and I need this. Whoops. 1, I guess. The proxy is required so the outside world. Oh, right. I guess that's true. Because you can't, again, we don't have type applications, right? Like that's the key. Thank you for just clarifying that. That makes perfect sense. So what is this complaining about? It wants. Oh, I think I used a double fat arrow, and I meant to change this to a dash. There we go. Okay, so yeah, now that we have the proxy, we can deal with this. It would be kind of cool if we could like just say, you know, like anything. So this was a trick that was showed to me. I forget how you even do it in Haskell, but like just give me something here. I don't care what it is. So like I wonder if you can just put like F here and it still works. Yeah, it does. So that's like, yeah. So it's just like, give me, yeah. And I guess it doesn't matter what order you put this in. So now you don't need a proxy. You can put whatever you want there as long as it's like, it can fix the type of element. So you could use identity, you could use proxy, etc. Yeah, so it's cool that you know the trick as well. I just learned about this. It's a clever idea. I always used Proxy for this because, like, I thought that, I mean, that's the whole purpose of, well, it's kind of one of the purposes of Proxy, but this is a cool little trick. Okay, so I think that this is like even slightly more generic tail than this one. Not by much, but it seems that we don't need to worry about Proxy. Like, it must just already be here, which is cool. So I guess the trick, pre-data kinds types like S proxy, R proxy. I have not used those enough to understand. So okay, now though we don't. The idea is I want to just try this. So, oh, we have to implement this thing now. So let's do that. We'll just grab the code points one. So we need this. And we need these. Oh, okay. I think that makes sense. I feel like I've maybe seen those before, but not 100% sure. So what is this part of? Data string? I've not been... Yeah, just strings. So spago install strings. And then we have to restart this down here. I hate that that is what happens. There we go. Okay, and then T. Oh, this is the hacky solution, which we're gonna skip. There's that. Wait, what's going on here? I lost where that thing was. I think I haven't gone far enough, but so we're in functional dependencies. Oh, okay, here it is. So no proxies, but like we're gonna actually. I just wanted to show this. I had lost my place for a second there. So this is like one example of this, but what I want to do, I think, is we can just write like anything here, like identity, and we could write like data identity a identity a, and it would be fine. An anonymous function argument appears in an invalid context. So you would have to like you I think I would need a literal identity here, which is certainly awkward, but it would maybe work. Oh, there is already an identity. Okay. In Prelude. So what's this complaining about? Okay, let's look up this string Unicode thing. Data string uncons. So string to maybe code point string. Oh, they're okay. I get it. These are the wrong maybe types. So we need to. It's very confusing to work in a single file here sometimes. So here we can now import. Oh my gosh. Data maybe. There we go. Okay. What's complaining about? Oh, this needs a character. Oh, and then we actually don't have an instance for this one. So this needs to be a code point, and then it can be like a stir. Maybe. Oh, it needs to be a code point. I don't know how to make a code point. How do I make a code point? It's a new type over what? Over an integer. Okay, so then we say code point 1, 0. Then it compiles? Nope, not yet. What am I pressing? Unknown data constructor. Hello? Unknown data constructor. I disagree? Maybe it can't make one of these? I don't understand. Like, does this imply that it's not exporting the data constructor? How do you make a code point? Okay, code point from character. This turned out to be more work than we wanted, but that's fine. Let's see. Do you compile? You compile. Okay, cool. So there we go. This is how you would use it without a proxy. Obviously, it's way easier to use with a proxy. I'm kind of surprised that I can't put an underscore here, but like again, I don't really know the semantics all that well. Like I don't need this thing, but there are apparently certain cases where you can use a function argument in some context and it will just work, which is kind of weird to me. So anyway, there we go. I haven't gotten that far yet, apparently. So there we go. Again, if you're using a proxy, you don't need this because a proxy doesn't take any arguments. The A is a phantom parameter. Okay. Oh, it's right here. There you go. All right. And I think that, yeah, we sort of talked about this already. Oh, that was the hacky solution? Unfortunate. I feel like that's not that hacky. The other one, well, I guess I didn't even finish the other one, but anyway. So the whole point is that we can write another version of generic tail. Let's use, let's grab this. Okay, so this is slightly unfortunate because we have to pass in a value with type to, or a value of f element. For example, proxy A. Okay. Now, I'm going to change this to behead. Okay. And then we're going to say we'll use the functional dependency, which is collection determines element or something. I forget the syntax. Oh yeah, there it is. So like given your collection, you already know the element, so you don't need to like worry about this at all. And so this simplifies this whole thing because we no longer need this f and the sort of proxy, and we can probably just remove all of this. And don't forget to remove the parameter. Oh, and then this is going to be generic, and this is going to be behead. And this needs to be a fat arrow. No, this needs to be a dot, and this needs to be a fat arrow. There you go. And this needs to be behead. Thank you, compiler. Okay. The compiler is your friend. Just never forget it. It holds your hand, and it makes your life a lot easier. That's the beauty of types. Okay, cool. So yeah, I kind of forgot about functional dependencies, even though the thing was titled functional dependencies. But these are pretty cool when you have these kinds of situations. All right. Except for the limitation mentioned earlier. So why? Okay, so now we get an overlapping instance error because we're saying that this string determines this type, and so now these things are like tied together. Before they were not tied together. So yeah, we want to reverse the functional dependency. That makes a lot of sense. So it's not the collection that determines, it's the element that determines the collection. That makes perfect sense. And that what? Oh, well, now we have a problem. Oh, but we have to be explicit here? Okay. Fine. I mean, I think that's totally fine. It's not that problematic. You only have to write that once, right? Like, that's the nice thing. And the error, I guess, should make me think that as well, because it says, wherever I went. Yeah, it doesn't know what T1 is again. It should call it, like, element something, N. but it's like, I don't know what T1 is. So we just need to tell it what T1 is, and it's an element. Okay. So, oh no. All right. So let's think about this one. So, yeah. So you're saying like anything A is a list. Super problematic. And by the way, I'm starting to see why the person, I was talking to somebody about this book and why they say they don't like it, because this is like, oh yeah, cool, this makes perfect sense, and like reverse dependency, great. Actually, there's a solution. We just reverse it, but then it like leads you down this other path, and it can be tricky to like decide what you're supposed to remember and what you shouldn't remember. But I guess it's like, I think the thing is or right now we really need to like weigh our options and think about the kinds of things that we can do. So we have a choice here. We can say that the collection determines the element, or the element determines the collection, and then like, what does that mean for this function? And then like try to ingrain that in our head. So if we do it this way, then we have this problem where if we put an A here, where we break everything, because it's, yeah, you can't do this. Hey Gil, what's going on? Squid. Okay. Yep. Yeah, when we had this flipped, okay, so now we're really getting into the weeds though. All right, so my feeling is that what was the issue with doing collection to element? Ah, right. So I almost feel like the proxy solution is not hacky, it's like the solution. What what do you think? Like, I feel like the quote unquote hacky solution is arguably the most flexible, because you can have instances, and especially in a case like this where you want to have a lot of different instances, like you're going to have instances for every collection, you're going to have both these limitations. Either this limitation where it's a problem going from like string to, although I guess this limitation happens less often, right? Like how like a string to character or string to code point, that's like a pretty specific thing, whereas this version where you have like a list or an array of A, like a collection is typically defined in this way, trees, I don't know, I can't come up with any more offhand, but like almost every collection is going to look like this. So you kind of almost want the collection to element version, and then do something special for character and code point with like a new type. That would be my guess. Okay, so let's write some notes here. So functional dependencies are useful based, so okay, so the Decapitate type class will fail if, wait, I don't use the Decapitate one's a generic one. Yeah, okay. Okay, so let's change this. Hang on. So when using behead, we have two options. Forward reverse. Forward fails with a case with instances like behead string car and behead string code point, because we are saying the collection, in other words, string, determines the element. However, we can convert each element, or sorry, a string an element in a string can represent multiple things simultaneously. Okay. This is less frequent an issue for containers, and therefore the reverse style might be preferred. Okay. One could also use new types to handle the car versus code point distinction. Is that? I feel like that's a decent comment. Because like this is pretty important. Okay, what did I spell wrong? Can't spell simultaneously. That's not surprising. And okay, the rest of it is just junk. Yeah, so that's like an interesting thought experiment. Like, you want to use functional dependencies. You have two options. Like, you can either have the forward, as in the first determines the second, or you can have the second determine the first. But you have issues when you want to do that. Like, I heard a knock, but who would be knocking? They'll ring the doorbell if they need something. Okay. Yeah, so in this case, like, you can use, so what they're saying here is you can use the reverse dependency in this case. Oh, wait. Did I have this backwards? No, the reverse one. Okay, so hang on. I think I did this backwards. So this is Okay, this is less frequently an issue for containers, and therefore the forward style might be preferred. One could also use new types to handle the car versus code point issue distinction or whatever. Yeah, I think that's fine. I just had this sentence backwards. So like then we don't need this because like this is kind of awkward too. Like, you would have like these chained else instances for all of your containers. But list will always match. Yeah. Okay. So that was chapter 6. And cool chapter. Definitely useful information about new types. Things like using proxies and for functional dependencies, all really useful tools. And then like next time we'll obviously dive into chapter 7 and we'll talk more about doing some code, writing some code. And I think that would be cool.